Start.
Yes, we are ready.
Our Honorable Chancellor is also here. So, शुरू करें?
Sir.
Focus.
So, let us start, Neetu.
Okay, sir.
Neetu शुरू करिए.
A very warm good morning to one and all. I, Dr. Neetu Kataria, welcome you all in 9th Vikram Sarabhai Memorial Oration. It is indeed a privilege to have such distinguished personalities over. Chief guest, Padma Shri Professor Shailesh Nair, Director, National Institute of Advanced Studies, Bangalore, and Chancellor, Terry School of Advanced Studies, New Delhi. Honorable Chancellor, Shri Vaishnav Vidyapit Vishwavidyalaya, Shri Purushottam Das Ji Pasari, Honorable Vice Chancellor, Dr. Upinder Dhar, Secretary, Shri Vaishnav Vidyapit Trust, Shri Kamal Narayan Ji Bradia, Coordinator of the event, Dr. Uttam Sharma, all respected head of the institutions and head of the departments of the constituent institutes of Shri Vaishnav Vidyapit Vishwavidyalaya, my esteemed colleagues, delegates, and dear students. India has a long history of scientific and technological achievements. From ancient times to the present day, countless Indian scientists have made significant contributions to science and technology, earning global recognition. Among them is Vikram Sarabhai, an eminent Indian physicist widely regarded as father of India's space program. Shri Sarabhai played a pivotal role in advancing space exploration and was instrumental in the development of India's nuclear capabilities. In the honor of Padma Vibhushan Shri Vikram Sarabhai, Shri Vaishnav Vidyapit Vishwavidyalaya organizes Vikram Sarabhai Memorial Oration since 2016. Foremost, I request all the dignitaries and audience to join traditional auspicious lamp lighting ceremony and Saraswati Vandana as a tribute to Ma Saraswati, the goddess of knowledge virtually. Thank you very much. Now, as a token of our gratitude and appreciation for our esteemed guest, I request our technical team to present virtual bouquet on behalf of Honorable Chancellor Shri Purushottam Das Ji Pasari and our Honorable Vice Chancellor Dr. Upinder Dhar sir to our chief guest Professor Shailesh Nair. Thank you. Though we may be miles apart, the warmth and respect we feel are no less than a beautiful gesture in person. Thank you very much, sir, for being with us. The life of Shri Vikram Sarabhai stands as a beacon in India's journey towards space and nuclear power. Dispelling the shadows of superstition and ignorance, his remarkable contributions continue to inspire future generations. He often says, he Who can listen to the music in the midst of noise can achieve great things, emphasizing the importance of focus and vision in the pursuit of greatness. His words and legacy continue to guide us towards achieving extraordinary milestones. With these words, I request our technical team to show the glimpse of life of Sri Vikram Sarabhai.
Vikram Sarabhai was known as the father of India's space program. It was Sarabhai who put India on the international map in the field of space research. He worked in the fields of textile, pharmaceuticals, nuclear power, electronics and many others. Vikram Ambalal Sarabhai was born on 12th August 1919 to a wealthy family at Ahmedabad. Sarabhai had his early education in the family-run school. After completing his intermediate science examination from Gujarat College, Cambridge in 1937, where he obtained his tripos in natural sciences in 1940. At the outbreak of the Second World War, he returned to India and joined the Indian Institute of Science at Bangalore, where he took up research in cosmic rays under the supervision of C.V. Raman. He published his first research paper entitled Time Distribution of Cosmic Rays in the Proceedings of Indian Academy of Sciences. His visit across several science centers enhanced his interest in solar physics and cosmic rays. In 1947, he also founded Physical Research Laboratory in Ahmedabad. In India, he studied interplanetary space, solar terrestrial relationships and geomagnetism. The most striking aspect of Sarabhai's personality was the range and breadth of his interest and the way in which he transformed his ideas into institutions. Sarabhai was a creative scientist, a successful and forward-looking industrialist and more. With support of Homi Bhabha, he played an important role in the establishment of first rocket launching station in Thumba near Thiruvananthapuram. After the death of Homi Bhabha in January 1966, Sarabhai was appointed as chairman of Atomic Energy Commission. Dr. Sarabhai was awarded with Shanti Swarup Bhatnagar Medal in 1962 and Padma Bhushan in 1966. On 30th December 1971, the country lost its great scientist and an innovator of the highest order.
Thank you. I kindly request our esteemed guest, Honorable Chancellor Sir and Vice Chancellor Sir, and all those present here to join us in paying a tribute to the revered Sri Vikram Sarabhai. Thank you. I now invite the Honorable Vice Chancellor Sir to extend a warm welcome to our guest with his kind words and gesture. Over to you, sir.
Our distinguished guest, Padma Shri awardee, Professor Shailesh Naik ji, our Honorable Chancellor, Shri Purushottam Das ji Pasari, Honorary Secretary of our Trust, Shri Kamal Narayan ji Buradia, all deans, directors, faculty members, and my dear students. Today, we are having this 9th Vikram Sarabhai Oration, which will be delivered by Professor Shailesh Naik. Before we will be requesting Professor Naik to speak, I would like to give a brief background about this oration. In January 2015, Madhya Pradesh government declared through a gazette notification Sri Vaishnav Vidyapith Vishwavidyalaya as a state private university. At that time, one of the challenges was that how we are going to be different from other universities in the country. How we are going to deliver the education different. One of the distinguishing features which I identified was to celebrate the achievements of great sons and daughters of our nation. So we started with an oration in the name of Aryabhat, which was delivered by Padma Vibhushan awardee Dr. Anil Kakodkar. Later on, we felt that we should have more such orations because this is an opportunity for the students to learn directly from those who have contributed significantly. So, in addition to learning from the books, because the achievements of great scientists and great scholars of the country are documented in the books, but then in addition to that, let the students and young faculty have interface with these great people. Therefore, we started after Aryabhat Memorial Oration. We introduced C.V. Raman Memorial Oration. Similarly, then Vikram Sarabhai Oration, Ramanujan Oration, Mokshagundam Oration, and so on. Intention has been to make students believe that great scientists have been in India also. When they read in the textbooks, they believe that scientists have been in West only. Great contributors have been in West only. Therefore, to break this myth, we want to repeatedly convey to our students the contribution in terms of Indian knowledge system and the great sons and daughters who have contributed significantly. All these orations are annual orations. And as I said, today we have 9th Vikram Sarabhai Memorial Oration. Vikram Sarabhai, a great son of the soil, was not only a great scientist, he was a great artist too. He was an industrialist too. He was an institution builder. There are so many big institutions, known institutions, which are making contributions their own way, were set up by, or he was involved in the setting up of such institutions, like even IIM Ahmedabad, which was the second IIM in the country. Indian Physical Laboratory in Ahmedabad. So many such institutions. Therefore, we felt that Padma Shri awardee Professor Shailesh Naik is the right person to deliver this oration and educate us more about what is happening in science today. Where do we stand? The whole world is looking at us, not only because India has progressed very significantly. India has made a mark at the international level, but also because our great scientists are recognized today all over the world. That recognition did not start today. This recognition, international recognition, was there even at that time when Vikram Sarabhai was chairman of Indian Space Research. This short documentary which we saw, it mentioned about Homi Jahangir Baba, again a great scientist. So I would like to welcome Professor Shailesh Naik on this occasion, and I'm sure that we'll be richer in our understanding about the contemporary science through his deliberation. So I wish happy learning to all faculty and students. Thank you very much.
Thank you very much, sir, for expressing our heartfelt affection and reverence to everyone present here and to explain the vision of these orations. I now request our esteemed Honorable Chancellor Shri Purushottam Das Ji Pasari to address the gathering and share his valuable insights with us. Over to you, sir.
नमस्कार। नवे विक्रम साराभाई स्मृति व्याख्यान के हमारे मुख्य अतिथि एवं वक्ता आदरणीय पद्मश्री डॉक्टर शैलेश नायक, निर्देशक नेशनल इंस्टीट्यूट ऑफ एडवांस्ड स्टडी बेंगलोर, श्री वैष्णव विद्यापीठ ट्रस्ट के सचिव श्री कमल नारायण जी भुरारिया, माननीय कुलपति श्री वैष्णव विद्यापीठ विश्वविद्यालय डॉक्टर उपिंदर धर जी, समन्वयक सेंटर ऑफ एक्सीलेंस प्लाज्मा रिसर्च डॉक्टर उत्तम शर्मा, सभी संस्थानों और विभागों के प्रमुख और सभी विशिष्ट प्रतिभागी जो इस ऑनलाइन प्लेटफॉर्म के माध्यम से हमारे साथ मौजूद हैं, सभी का हार्दिक स्वागत करता हूं एवं अभिनंदन करता हूं। विशेष रूप से हमारे मध्य आज हमारे मुख्य अतिथि एवं वक्ता पद्मश्री डॉक्टर शैलेश नायक जी का विशेष रूप से अभिनंदन करता हूं, जिन्होंने यहाँ इस प्लेटफॉर्म पर आके हमें गौरवान्वित किया है। बंधुओं, श्री वैष्णव ट्रस्ट एवं इसकी सहयोगी संस्थाओं ने गत 140 वर्षों से इंदौर शहर में नर सेवा नारायण सेवा मंत्र को आधार मानकर जन सेवा एवं जन कल्याण के अनेक प्रकल्प संचालित किए हैं। वर्ष 1884 में इंदौर के वस्त्र व्यवसायियों ने स्वयं के व्यवसाय पर शैक्षिक टैक्स लगाकर श्री वैष्णव सहायक कपड़ा मार्केट कमेटी की स्थापना की। सभी पूर्ववर्ती संस्थापकों की दूरदर्शितापूर्ण नीतियों के क्रियान्वयन के फलस्वरूप संस्था द्वारा सर्वप्रथम 1925 में श्री वैष्णव अन्न क्षेत्र एवं श्री रामकृष्ण बाग एवं 1934 में श्री वैष्णव आयुर्वेदिक औषधालय की स्थापना की गई। सन 1951 में शैक्षणिक क्षेत्र में श्री क्लाथ मार्केट वैष्णव हायर सेकेंडरी स्कूल की स्थापना की गई। इसके पश्चात 1962 में वैष्णव पॉलिटेक्निक, 1967 में वैष्णव वाणिज्य महाविद्यालय, 1981 में श्री क्लाथ मार्केट वैष्णव बाल मंदिर, 1992 में श्री वैष्णव कन्या विद्यालय, 1993 में वैष्णव एकेडमी, 1995 में श्री वैष्णव प्रौद्योगिकी एवं साइंस संस्थान तथा 2005 में श्री वैष्णव विधि संस्थान तथा श्री वैष्णव शिक्षक प्रशिक्षण महाविद्यालय स्थापित किया गया। आज इन सभी संस्थाओं में 23,000 से अधिक विद्यार्थी अध्ययनरत हैं। सन 2015 में श्री वैष्णव विद्यापीठ विश्वविद्यालय की स्थापना मानवता के बेहतर भविष्य के उत्थान को उत्कृष्ट शिक्षा, प्रशिक्षण एवं अनुसंधान के माध्यम से उत्थान करने की दृष्टि से की गई है। विश्वविद्यालय का उद्देश्य ऐसा उत्कृष्ट शैक्षणिक वातावरण प्रदान करना है जिससे कि बौद्धिक, नैतिक एवं आध्यात्मिक प्रेरणा मिल सके एवं मूल्य आधारित नेतृत्व की क्षमता को पोषित किया जा सके। स्थापना के अल्प समय में ही विश्वविद्यालय प्रादेशिक एवं राष्ट्रीय स्तर पर उन्नतिशील संस्थान के रूप में अपने आप को प्रतिष्ठित करने में सफल रहा है। विश्वविद्यालय हम कई नवीन पाठ्यक्रम का संचालन कर रहे हैं, जिसमें बिग डाटा एनालिटिक, इंटरनेट ऑफ थिंग्स, मेकाट्रॉनिक्स, फॉरेंसिक साइंस, एग्रीकल्चर इंजीनियरिंग, आर्टिफिशियल इंटेलिजेंस, सोलर एनर्जी जैसे कई नए कोर्सेस हैं। बदलते समय के साथ विद्यार्थियों को ऑनलाइन कोर्सेस तथा इंडस्ट्री की जरूरतों के हिसाब से भी नए विषय पढ़ाए जा रहे हैं। हम लगातार अपने विश्वविद्यालय में उत्कृष्ट एवं नवीन तकनीक से शिक्षण कार्य करा रहे हैं। आज जब सभी भारतीय ज्ञान परंपरा को आगे बढ़ाने के लिए बात करते हैं, मुझे हर्ष होता है कि श्री वैष्णव विद्यापीठ विश्वविद्यालय प्रारंभ से ही इस दिशा में कार्य कर रहा है। भारतीय ज्ञान को जानने के लिए आवश्यक है कि हम भारतीय वैज्ञानिकों को जानें और गर्वित अनुभव करें। आर्यभट्ट, डॉक्टर श्रीनिवास रामानुजन, सर सीवी रमन, विक्रम साराभाई, मोक्षगुणम विश्वेश्वरैया जैसे महान भारतीय वैज्ञानिकों की स्मृति में स्मारक भाषणों की श्रृंखला आयोजित करने में विश्वविद्यालय के प्रयासों की सराहना करता हूँ। ये व्याख्यान युवाओं को समाज के विकास में भारतीय वैज्ञानिकों के योगदान का स्मरण कराते हैं और साथ ही ये प्रख्यात वैज्ञानिकों और विद्वानों के साथ बातचीत करने के लिए भी एक मंच प्रदान करते हैं। मैं इस ऑनलाइन मंच पर श्री वैष्णव विद्यापीठ विश्वविद्यालय में हमारे आज के वक्ता पद्म श्री प्रोफेसर डॉक्टर शैलेश नायक का समुद्र विज्ञान के क्षेत्र में किए गए अनुसंधानों के लिए विश्वविद्यालय परिवार की ओर से अभिनंदन करता हूं। आपके द्वारा स्थापित हिंद महासागर में सुनामी और तूफान की लहरों के लिए एक अत्याधुनिक प्रारंभिक चेतावनी प्रणाली, वायु प्रदूषण मॉनिटरिंग सिस्टम, समुद्र जीआईएस की अवधारणा और विकास, संभावित मछली पकड़ने के क्षेत्रों के पूर्वानुमान आदि अनेक अनुसंधान मानवता को दिए गए आपके अनमोल उपहार हैं। ऑनलाइन माध्यम से इस कार्यक्रम में आपकी उपस्थिति के लिए मैं आपका आभार व्यक्त करता हूँ। यह व्याख्यान निश्चित रूप से युवा मन को प्रज्वलित करने के उद्देश्य से पूर्ति करेगा। धन्यवाद। जय भारत।
Thank you very much, sir. The journey of Sri Vaishnav Vidyapeeth Trust inspires us, showing the great achievements begin with small steps. We are confident that with your vision and support, and under the guidance and expertise of our VC sir, the university will reach new heights of success. Thank you very much, sir. We are truly honored to have our esteemed guest, Professor Shailesh Nayak, with us today. Professor Nayak's exceptional achievements and contribution have earned him widespread recognition, although he needs no introduction. I now request Professor Uttam Sharma, coordinator of the Center of Excellence in Plasma Research, to formally introduce Professor Shailesh Nayak to the audience. Over to you, sir.
It is a matter of pride privilege for me to read the citation for Padma Shri Dr. Shailesh Nayak. I quote, Dr. Shailesh Nayak is currently Director, National Institute of Advanced Studies, Bengaluru, Chancellor, Terry School of Advanced Study, New Delhi, Light Trustee, Indian International Center, New Delhi, and Editor-in-Chief, Journal of Indian Society of Remote Sensing, Dehradun. He obtained his PhD degree in geology from MS University of Baroda in 1980. He was Secretary, Ministry of Earth Sciences during 2007 to 2015 and provided leadership for programs related to Earth system science. His current research interest includes building strategy of blue economy, sustainable development, and promoting research in the Indian Ocean and polar regions. He had set up the state-of-art tsunami warning system for the Indian Ocean in 2007 and provided tsunami advisories to the Indian Ocean rim countries. He has pioneered the development of algorithms and methodologies for the application of remote sensing to the coastal and marine environment and generated the baseline database for Indian coast and developed services for fishery and ocean state forest. This coastal database had formed basis for managing the Indian coast. He was instrumental in creating database for the glacier of India, Himalaya. He is the fellow of Indian National Academy of Science, Allahabad, the Indian National Science Academy, New Delhi, Indian Academy of Sciences, Bengaluru, fellow of the International Society of Photogrammetry and Remote Sensing, and academician of the International Academy of Aeronautics. He was President International Geographical Congress during 2015 to 17. He was conferred the prestigious ISC Vikram Sarabhai Memorial Award in 2012 and Bhaskara Award in 2009 for his outstanding contribution in remote sensing and GSI. He has published about 190 papers in peer-reviewed journals. The government of India conferred on him the fourth highest civilian honor, Padma Shri, in recognition of his outstanding contribution in the field of science and engineering in 2024. Sri Vaishnav Vidyapeeth Vishwavidyalaya is privileged to present this citation to Dr. Shailesh Nayak for delivering the prestigious 9th Vikram Sarabhai Memorial Oration as distinguished speaker on 5th December 2024. Unquote.
Thank you very much, sir. I request our technical team to present the citation to Professor Nayak virtually on behalf of Sri Vaishnav Vidyapit Vishwavidyalaya. Thank you very much, sir. Without further delay, I now request Professor Nayak to kindly deliver the 9th Vikram Sarabhai Memorial Oration on the topic Towards a Sustainable Blue Economy. Audience are requested to kindly submit their doubts or questions in the chat box for the question and answer sessions, which will take after the oration.
Thank you very much for this opportunity. I'm extremely grateful to Sri Vaishnav Vidyapit Vishwavidyalaya, especially Dr. Upinder Garg, Vice Chancellor, and the Chancellor for giving me this opportunity to interact with you and the students. I must compliment the Vidyapit for initiating this oration in the memory of Dr. Vikram Sarabhai, who not only set up various institutes, especially in the space related, but also related to management, textiles, chemicals, and many others. But the most important thing which he did, in my view, is the working culture which is set up in ISRO. You can see that today one of the most successful research organizations in the country is the Indian Space Research Organization. And each and every citizen of the country is very proud of the achievement of ISRO. I was fortunate to work about 28 years in ISRO and learn how and why Sarabhai was so successful. His main, the picking up right people and putting full trust and autonomy in a person to deliver the goods. He brought several people, right from Abdul Kalam, Professor Govarkar, Professor Rao, and many others who actually did the growth of this great institute. So I am very thankful to Professor Upinder Garg for inviting me for this and bestowing this honor to deliver the Vikram Sarabhai Memorial Oration. I thought I will speak about the blue economy. Many of you may be aware of the discussion which is happening in this country, not only this country but all over the world. Those who have been keeping the G20 had a major para on doing the blue economy. So why the ocean has become very important? Oceans are very important because we all know that it provides us food, energy, resources. Also, it controls the weather and climate, and overall, it can it provides an ecosystem which is for us to make the planet healthy. Realizing this, the UN Conference on Sustainable Development also stressed that we need to move from the green economy to the blue economy. This is because of the climate change. We realize that the as the resources are depleting on the land, we will have to depend more and more on the ocean. And this again translated into the Sustainable Development Goals, where we have said that we conserve and sustainably use the ocean, seas, and marine resources. Now, so the focus on this ocean in last couple of decades has increased tremendously, and that is why the current decade has been declared as the care of the ocean science for the sustainable development. Is essentially to provide the information and the science required for the development of the oceans. Now, the blue economy term came up uh, recently, and essentially it means that it has to be an ocean dependent economic development of the country, basically to improve the life of its citizens. However, it's not only the development, but we have to ensure the ecological and environmental security along with the social development of people. So it is more of an inclusive than the current model of the development where the environmental, ecology, and the social, all three aspects are into.
Excuse me, sir.
Yeah.
Sorry to interrupt, sir. Sir, slides are not moving.
Oh, the second slide you are not able to see.
Sir, we are at the first slide only.
Okay. Okay.
Yes,
We
sir.
reached
Yes,
that.
sir. Yes, sir. Now, blue economics. Thank you, sir.
Yes, it's more.
This you can see.
Yes, sir. Sir, it's very, we are not able to see clearly. Can you do it full screen mode, sir?
Yeah. Now,
Sir, it's not on full screen.
full screen is not seen.
Yes, sir.
Now, can you see?
So it's okay, sir. Visible.
Blue economy is visible now.
Yes, sir. It's visible.
Okay. Okay. So, what I was, there are several aspects of the blue economy. Naturally, the resources, both marine and non-marine. Also, the tourism. Also, the issues related to shipping industries, hazards, and the overall management. So, these are some of the components of the blue economy. And I will try to give a brief description of each of this aspect. So first let us see the marine bioresources. Now, India has, as you know, that
Which is
yeah. So the fishery is one of the most important resource, and as we know that almost 9 million people in India are dependent on the marine fisheries and various activities. There are more than 7 lakhs fishermen, so it's a very important component of our economy. Now, our total yield which is possible is about 5.3 million tons, but on an average we have been harvesting about 3.8 million tons, and the most of this we are within the sustainable levels. So there is a one lot of people think that we are overfishing and all, but which is not true. 90% of our fish catch is within the sustainable limits. Now, the main issue with fisherman is how to find a fish, and the most of the time for them for the searching the fish. So in India we have a system what we call as a potential fishery advisories, which is based on the satellite, and I must say that this was visualized by Vikram Sarabhai in 1969 when he wrote about the vision, and this of course became started somewhere around 2000, which is uses the satellite-based information about chlorophyll the chlorophyll is used as an indicator of the food for the fish, and the second is the sea surface temperature, which indicates the environment in which fish would like to stay. So when both these parameters, the food that is the phytoplankton and the sea surface temperature are conducive, the fish likely to aggregate. So based on this, we have been providing the advisories to the all along the Indian coast in local languages, and this has proved to be very useful for the fish. The not only the success rate has gone up, but they started getting 2 to 4 times more catch, and their search time is reduced more than the 60%. So when the search time is reduced, they use the fuel use has become reduced, and that much less carbon dioxide is being put into the atmosphere. So there is an environmental benefit as well. So this is one. The second thing which is very important which has happened, that earlier the fishermen used to do the water trawling, which used to damage tremendously the ecology of the ocean. Now after this, they have been using the gill netting, which is more environmental friendly system. So this one uh, kind of advisory, which is satellite based, which has tremendously helped the fishermen economically as well as the environmentally. And this is the benefit which has come to the fisherman. For each trip is something like 17,000 rupees. So this is the one of the most important aspect. And if you take the carbon credit, it's a huge benefit, about 2.8 trillion rupees. It's a huge benefit in the terms of the carbon credit. So this is the one which is now also been taken under Pradhan Mantri Matsya Sampada Yojana. So it's being promoted. So this is a sustainable and environmental friendly way of providing the input to the fisherman. Now, the next thing which we have been doing is that we know that whether we can also estimate what is the likely stock of the fish in a particular region. We know that the fish, the accumulation of the fish depends, as I told you, on various physical, chemical, and biological processes, and this keep on changing from season to season. Now, the satellite provides the monthly climatology of the sea surface temperature and chlorophyll and the other parameters such as the sea surface currents, and all this information together, we can put them into a model which can provide a annual total stock available for the fish. So as I told you that our average is around 5.3, but this keep on varying. So we can estimate the yield of the particular season, and accordingly we can direct the fisherman. So this advisory which I showed you, we would like them to become a ecosystem-based advisory for the coming years. Now there are certain drawbacks. There are harmful algal blooms, which is a sort of a phytoplankton will they grow much more in size because of the pollution or the temperature rise, and essentially lowers the oxygen levels, and this is harmful for the fish. So this service is also provided to all concerned so that they do not fish in the areas where there is likely to be a harmful occurrence of harmful algal blooms. Now, this is a real-time information, but we are in the process of developing early warning system. That is, next 3 to 4 days, what kind of blooms are likely to form, which is also being planned. Now, apart from this fishery, we have a lot of resource of the big fishery. Uh, that is almost 3.3 million tons on an average, which is not being exploited as of now. Most of our fishermen fish within the first 100 meter or so. So this is an area which is to be developed. We have a new fisheries like petrofits, which is almost 100 million tons, which could be used for the this not table fish, but could be used for the poultry and the livestock as a food for the livestock. So which is also another possibility. We have also a lot of other technology which is developed, which is the rearing the fish in the cage culture, what we call as the mariculture. Then there is the ornamental fishery, and also the bioactive compound which can be used for the fish. So there are a lot of things which can be done for the living resources. Now this living resource.
Sorry, sir. Excuse me, sir. Sir, again slides are not moving. We are at blue economy.
Oh, but you are not told. I thought it is moving.
Yes, sir. Yes, sir.
Now, ma'am,
Yes, sir. Yeah, with coastal ecosystem.
in this system it works.
But when you do
Go to full screen, then it goes over. It stands still.
why? It should happen, no? You make it full screen.
Now is it visible, ma'am?
Sir, there is not full screen, sir, so we are not able to read it.
Now?
Should I change?
Yes, sir.
Now it is in coastal ecosystem, ma'am?
Yes, sir. Yes, sir. It's a,
Is it moving now?
it's not moving, sir.
Should I change the system and
No, you just
you
go
wait
ahead.
for 2-3 minutes?
Yeah, sure, sir. No issues.
Yeah.
So go to the full screen.
Now, Mari, you set up my laptop. I come there. Here it is not working.
Professor Nayak will be join shortly. There is some technical issue in his system. He'll be back with 2-3 minutes.
Can our technical people help?
No, sir. There is some issue in his setup.
He'll be joining in a few minutes, sir. He's going to switch on the other system.
I'll do that. Is visible now?
Yes, sir, it's visible, sir.
Okay, thank you.
Yes, sir. Thank you very much, sir.
Yeah. So this was visible, right?
Yes, sir. It's moving.
From here, it was not there, right?
Yes, sir, it's changing now.
Changing, no? Okay.
Yes, sir. Yes, sir.
Okay. So I'll briefly touch this aspect, the potential fishery zone. The fishery is one of the most important aspect, and the the fisherman has to spend a lot of time and energy to search for the fish. So since 2000, we have introduced a service which is called Potential Fishing Zone Advisory, which is dependent on the satellite-based information on the phytoplankton, which is coming from the chlorophyll, and the sea surface temperature, which provides the information about the environment. So when both these are matching, these are the areas which is suitable for the fishing. So this information is provided to fishermen in the all local languages through various means. And the what is found is that the reduction in the search time was reduced by about 30 to 70%. So that much less fuel they have used. Also, they got a better catch, and the success rate is almost 80%. So this proved to be economically very beneficial to uh, the fishermen, and at the same time, it also provided the environmental benefit, as I told you, as the environmental benefit because of the issue of the putting less carbon dioxide into the atmosphere. So those things help quite a bit to have the inclusive kind of a system where you also have the not only the economic benefit, but also the environmental benefit. So this is one of the most important aspect of the blue economy where you can have the sustainable development. So this is one case of this kind. Now, true sustainability can come once you know that the how much fish is likely to be available in a given season. So this is, we are now trying to develop a model based on the monthly phytoplankton and sea surface temperature. You can see that similarity between these two. Don't go into the details, but this kind of information we are trying to integrate. That means physical and models and chemical models along with the biological models we want to integrate so we can know that how much fish stock is available. This is something like what we do for the wheat and rice. For the before harvest, you get the production estimate. So once we know that, we can plan our fishing activities accordingly. The other major issue, which is uh, important to know, is there are certain harmful algal blooms which reduces the uh, availability of a fish. Now, this phytoplankton is the abnormal growth of the phytoplankton, and this essentially lower downs the oxygen and can affect the fishery. So this service is also available, and we are likely to convert this into a warning system. There are many other aspects of ocean. One is the deep water fishery, which we are not doing. The potential is almost 3.3 billion tons. Also, the new fishery resources, the myctophytes, which could be used for the poultry and livestock feed. Also, the cage culture, where you can rear the fish in a cage in a sea. Also, the ornamental fishery. Many people have the fish in their home, but most you know that it is all imported. So we have now started developing our own ornamental fish in the Laksvik, which has also huge potential. And of course, there are a lot of bioactive compound molecules which could be used for the development of drug. So the lot of things can be done on this, but these all will depend on the uh, health of the ecosystem, and the mainly the mangrove coral reef and seagrass is very critical, and we need to understand their structure, function, and whether they are vulnerable to climate change or not is very critical. Now, this ecosystem provide lot of services apart from the provisioning service. That means they provide fishery, timber, etc. Also, there are many other services like sequestering carbon dioxide. uh, they also afford the aesthetic values of tourism. So there are many other services which is provided, and this services we have to find what is the economic value of those services. Like the mangroves has an economic value about 3,300 US dollar per hectare per year. So it's a huge benefit from the ecosystem. So we need to protect this ecosystem, which is also economically very useful. Now, if you see the mangroves, fortunately in India, we have been monitoring this mangroves from 1987 on. Every 2 years, the Forest Survey of India gives the maps and provides the input about the changes which are taking place. And you can see that in the last almost 40 years or so, the mangroves have increased by about 1,000 square kilometers. It was somewhere around 4,000, and now it has increased to nearing to about 5,000. And the important thing which I would like to point that the major increase has occurred in Gujarat and Maharashtra, which are more industrial nations. So sometimes people think that the industry is the major reason for the destruction of the ecosystem, which is by the data shows completely opposite. So basically, it is the awareness of the people which can protect the ecosystem. So this is very important thing which has come out, and also the total carbon stock which is available is 52.5 million tons. So this is a huge carbon credit also comes from this ecosystem. The second ecosystem, which is very important, is the coral reef. And coral reef, of course, those who have gone to Lakshadweep or Andaman would know the value. Uh, it's very important from fishery point of view, biodiversity, tourism, and many other things. And the economic value of the coral reef is almost $3 million per hectare. So this was study done in Indonesia. We have yet to do this kind of a study in India. But so it's a huge economic value of protecting the ecosystem. Now, you must be also reading about the warming. Because of the warming, many corals are getting bleached. Now, what we have seen that the bleaching which happens, that the soft, there are two major types of corals. One is the soft called echopora and the hard called porites. Now, the soft coral gets affected by the warming, but we have also seen that they build some kind of a resilience to the warming. So when the second warming comes, this acropora do not get affected by this. So they also build certain resilience. So we have been seeing that the coral reefs are available in Persian Gulf, where temperature can go up to 36 or 37 degrees. So only because of the rise in the temperature, the corals are not likely to be lost. That is what one thing which we have been realized. But the important thing we should know that the acidification of the oceans, so the increase in the pH can dissolve the calcium carbonate. Because these are all calcium carbonate, their home is all calcium carbonate. So that is an area which is we have to worry about. And what we need is that how this pH values are going to change over a period of time. With that is what we need to understand for the health of this ecosystem. So the temperature along with the increase in the pH can be very detrimental to the coral reefs. And this, if corals are getting affected by this manner, there is tremendous loss of the economic value. So this is very important for us to protect this. The biodiversity is very critical because of the various reasons. And India has a very unique program called Census of Marine Life, where each grid, 3 degree by 3 degree, all the kinds of life from surface to the seabed is analyzed, and you can see this, all the dots which you are, for which we have a detailed information. And all this information is placed in what is called as the Ocean Biogeographical Information System, which provides you, there are standards, international standards, and provides you the information about the structure, function, and the vulnerability of the ecosystem. So this is another area which is also very critical, because the protecting biodiversity ultimately helps to maintain the health of the ecosystem. Now, India has a very unique program to promote the tourism, and those who have gone to some of the beaches know about the blue flag beaches. So this program, what we are doing is we are trying to identify certain beaches which meet the water quality, the security, the aesthetic value, all these parameters where it meets, the certification is given as a blue flag. This is an European-based company, and there are a lot of criteria to define the blue flag beaches. We have 12 beaches in the country which is identified as a blue flag, like the Radhanagar beach in Andaman, in Pondicherry, in Orissa. So each state has some of the beaches identified as a blue flag beaches. And apart from the safety and the aesthetic value of there are certain facilities like for changing rooms, the shower, etc., also provided in this. So this also we found that after declaring this beach as a blue flag beach, with certification has to be renewed every year, the income, those where the people are charging some fees, has gone up, and they are becoming self-sufficient So to maintain this kind of thing, the government do not have to spend any money. On the contrary, they also earn some money. The fees are not much. It is 5 rupees or 10 rupees for the entry, but the all other facilities are available. So this is one good thing which is happened in India, and the plans are that we would have about 100 beaches of this kind. The mineral is the another major area which is very important, and we have a huge minerals, the coastal placer minerals, which are like ilmenite, rutile, garnet, zircon, which provides you many rare earths and the minerals elements like titanium. Also, the monazite, as you know, provides you thorium. So this is the huge quantity available, and total value is about 150 billion. Now the government has identified certain block and it is being auctioned for the exploration. So this is another area which is very critical. At the same time, we are also exploring the minerals in the deep sea. Many of you may have heard about the polymetallic nodules in the central Indian Ocean. Now that is being done. We have already identified the areas where we have surveyed about 75,000 square kilometer area, and the first mining site about 12.5 kilometer by 12.5 kilometer is identified. Now, what you get in polymetallic nodules is manganese, copper, nickel, cobalt. And the copper, nickel, and cobalt, as you know, is very critical today because of the emphasis on the renewables. And the total value is about 187 billion. Similarly, there are polymetallic sulfides which are currently under exploration, where you get copper, lead, zinc, along with the gold, silver, and etc., which is also very important for us to the explore. The exploration is going on, and soon we would know where we would be able to mine them. The third, cobalt, is very important, as you all know, and we have also located cobalt enriched areas, and the exploration will be coming soon. But all these minerals are very deep in the sea, about 3,000 to 6,000 meter below. So you need to build a very specific technology to harness this. And for this also, we have now a the technology to be built for this, and it is under process. Like how do we go there and collect this, crush them, and it has to be brought up. So all this technology is under development. Also, the submersible is another major area which we need to build, which is also under development. The when you have a large amount of activity which is happening on, either in ocean or near the coast, the water is very important, and there are several ways and means people are trying to convert the ocean water into a fresh water, mainly through RO, because you must have heard about the RO. Everybody's home also the RO plant. But as you know that the RO, the discharge from the RO plant is a highly saline. And when you release them into the ocean, the marine life gets affected. So we have developed another method, which is called a low temperature thermal desalination. This is in this, what is done is the seawater is brought to a vacuum chamber, and as you know that it will start anything in vacuum, it will start boiling at a 22 to 25 degree temperature, which is a surface water temperature. And you collect the vapor into the another chamber and bring the cold water from the ocean bottom to cool down, you get a fresh water. Now, this is a very simple process, but engineering very difficult.
And this kind of a plants have been installed in Lakshadweep. For last 20 years, they've been working. And the advantage of getting the fresh water is that the gross product, where GDP of the Lakshadweep had increased by 11% after they get the fresh water. Earlier, the fresh water was not available on this Lakshadweep island. Now, same thing can be done into the thermal power stations also, and we have been suggesting that this should be done to provide the fresh water, which could be also boiler quality as well as for the drinking water can be done. Now, the large scale, if you want to produce, these are the small plants which produces about 100,000 to 150,000 liters per day. But if you want to supply to a city, you need million or 2 million liters per day. So we have now or 10 million liters a day. So the how this can be done from a ocean, the project report is ready. Once the funds are available, that also can be done. And this technique is environmental friendly because we don't use the entire water, only the 10% of the water is used. So whatever you discharge back is more or less same kind of a seawater and it assimilates pretty fast. So this is another technology which is now done. Also, there are many other things which is now under research, that there are several uh, minerals like nickel, uranium, cobalt, which are available in the seawater and brine. And the techniques are being developed so that we can retrieve directly these elements from this seawater or a brine. So these are also under development, and many critical minerals like lithium, copper, all this. So these are under the lab scale, development scale, and in coming years we would be able to provide a minerals also from the seawater. So these are some of the deep sea technologies like soil tester. You can test the mechanical strength of the soil at the seabed. Also, a remotely operable vehicle where you can put a payload up to 150 kg, and that you can measure the properties. There are robotic arms, so you can collect the samples. This is collecting the nodules, so we call a crawler, and this is a to drill in the seabed up to 100-meter is called. So there are different. There are several other technologies. Just an example I'm showing. The vessel which can go up to 6,000 meter Matsya is also under development, and this is being done with the IIT Madras, DRDO, and ISRO, all joined together to build this kind of a system. This system will be tested up to 500 meter very shortly, and after that testing, it will be taken to 6,000 meters. The ocean energy is another important aspect. There are, apart from the fossil fuel which you get from ocean, there is another, what we call as the gas hydrate. That means ice-like crystalline form of methane is very promising. We have huge reserves of gas hydrate, and this is the only problem is this is under pressure. It's the methane gas. You have to bring them under same pressure. Otherwise, the gas will escape to the atmosphere. So there are technologies which is being developed for this gas hydrate. The offshore wind farms are also being developed. So there are a lot of things which is developed on the energy front as well. Now, once you have a large amount of development of the coast and oceans, you have to worry about the hazards as well. And the hazards, the first thing is you must know what is the vulnerability of a coast. So we have a method which takes care of many aspects, like how the shoreline is changing, what is the sea level what is the slope, what are the wave height coming, tides, the elevation of the coast, and the geomorphology. All these parameters are put together, and the maps are prepared to find out which are the vulnerable areas. You can see this is a part of the map where these reds are the vulnerable areas. The yellows are not that moderately vulnerable, and this is less vulnerable. So when you want to set up any industry or any settlement, you can take care of the less vulnerable areas so that you don't have to worry about the hazards which are coming. So this kind of information is available for the entire country, and this is one of the major aspects of the blue economy. So these are the, how do we decide? We have the information about there's a shoreline. This is in the Orissa coast. You can see that in last almost 50 years, how the things have changed. This is 73. I have not put all the images, but we have up to 24. How the things have changing. Now, this kind of information is being generated for the entire coast every year based on the satellite images to provide that where and what kind of changes are going on. And we try to understand that these kind of changes are very critical. And this is information will be useful for many industries, cities, and all. And wherever there are settlements or something, you can provide engineering solutions to protect this shoreline. Cyclone, you know that over a period of time in last 20 years, we have drastically improved our predictions about the time at which the cyclone is likely to hit, where it will hit, and with what intensity. You have seen the recent one also was predicted pretty well, and we have been able to save a lot of lives. In 99, when Odisha cyclone came, 10,000 people died. Now, people which you find the loss, live loss are about 10, 12. In Bengal also, it was about 12. So, drastically reduce the lives. So, this is a very important aspect for the safety and security of the people who are living on the coast. Of course, there are further improvement we have been planning, especially related to the rainfall which is associated with this, and also the intensity, whether we can further improve. So a lot of experiments are being continuously done to further improve upon our prediction of cyclone. Similarly, we have a very good system on the tsunami warning system in Hyderabad. And here also, we have been able to provide the information not only to the India, but all along the Indian coast within 10 minutes of the earthquake occurring anywhere. That means this is an area which is the Andaman Nicobar Indonesia arc zone and the Makran coast. Now, what we have done, which is very innovative, is we are providing information at a 1600, 1800 coastal forecast points. That means all these dots which you are seeing. So we are providing every 50-kilometer away what kind of a tsunami is likely to come, not a general forecast that you may get tsunami in Bay of Bengal or in Arabian Sea. This is very important because you can't evacuate people from a very large areas. So this method has been working for last 17 years extremely well and without a single false warning. And this India has now been recognized as a regional tsunami warning system for Indian Ocean because we are the only country which provides the tsunami warning both for the Makran coast and this coast. So this is one of the very important development in last couple of decades where we have been able to generate the information which is very useful to save lives. The urban floods is very important, and you have seen during recent cyclone also there were flooding event in many areas, including Chennai and Pondicherry. So we have very complicated system. Actually, the urban flood is a very complicated thing, unlike the normal floods which you get in a river. We won't go into the details of this. This plot is only to show you how complex it is to develop the uh, forecast for the urban floods. But what is important is the final output, which is very useful for the decision makers, is very simple. This is only tells you which are the areas are likely to be flooded, and depending upon its color, like the uh, red is more than 3 meters, the orange is 2 to 3, and yellow is 0 to 1. So you would know immediately that which are the areas are likely to be flooded, what level of flooding, and this is superimposed on a map, which is a ward-wise map. So you would know which wards are affected, and also you may be able to see the roads and everything. So you could know that from where we should be able to approach them. So this is the kind of a system now put in place for Chennai and Mumbai, and for the other cities will be set up very soon. Now, the shipping, the one of the most important thing, there are many aspects, but I am not taking up. The what is the sea state? What would be the level of waves, currents, etc., happening into the sea? So we have been providing this information for about 3 to 6 hourly forecast, 5 days in advance uh, to the all ports. Actually, it is provided very highly local for each port, or to Arabian Sea, Bay of Bengal, or to the entire Indian Ocean, or to the global as required. And this information is provided to many countries also, like Sri Lanka, Maldives, Seychelles, Mozambique, Madagascar, and many other countries, this information routinely. Now, all this requires a very sound management of the, and India is one of the few countries who has the coastal zone management plans for the entire country. Now, in our country, what we call as a coastal regulation zone, the 500 meter from the high tide line is called as a coastal regulation zone, where certain activities are either prohibited or restricted or regulated. So this, what are restricted and regulated, this kind of maps are available for the entire country, and this is done by the National Center for Sustainable Coastal Zone Management, which is under Ministry of Environment and Forest. There are other centers like National Center for Coastal Research, which provides the routine information about the shoreline change or the coastal erosion every year. And the INCOIS provides the information about the inundation, where for any kind of inundation. So collectively, we have all the information to manage the coastal and marine area. Now, currently, what we have been trying to do is there is so much information. So all this information is now converted into a digital form, and the all kinds of different data sets, which could be scientific, which could be social, which could be economic, which could be environmental, trying to put them together and to integrate, and you get information in a particular area or a particular spot or along the transect, all in a 3 dimension. So this is now being done, which you can do animation and all this. This is also is under process. Now, the most important thing, because of the climate change, you need to provide advisories which is seasonal to decadal time scale. That what is likely to happen this year in season, as well as into the different scales like sea level, the cyclone, storm surge. All these information should be possible to give on a climate scale, that means decadal scale. So this is another area which is being done. And In the end, I would like to say that to have the sustainable and climate resilient economy, there are few things which we need to do. One is the coastal and marine spatial planning, so that we know that what are the risks and how we can avoid or mitigate those risks. Since we are talking about sustainable, what are those indicators which we can say that the system is under sustainable? So we need to identify those those indicators for various services. The other thing, as I told you, to bring different data sets, and we should build an integrated accounting system for which also their work is being done. Ultimately, we need to also build the capacity at a different level, institutional level, in regional level, as an individual level. So large amount of training is also required, and we need to build institutes framework, because as you see that when you want to do blue economy, there are different sectors. There are science and technology about it. Then you have a fisheries, you have a shipping, you have a mining, so very tourism. So all kinds of sectors are there. So we need to build a framework for the how these different institutes would be able to work. And I'm sure that the investment which we are going to do into oceans, which will definitely pay dividends for securing the future of our generations. So thank you very much for this opportunity. And I'm extremely sorry for this. Something happened in that system which was not happening, but I think ultimately we could do this. So thank you very much.
Thank you very much. Thank you very much, sir, for your wonderful explanation on blue economy. As earlier it was okay, but now it's very clear, and we have understood what you have explained. Now the session is open for the question and answers. First, I would like to ask panelists.
Thank you, madam. Thank you, sir, Professor Sailesh. It was a wonderful lecture. Actually, you have cleared us about HABs, invasive species, coral bleaching, thermohaline circulation. These are all the challenges which we are facing in the sustainable blue economy. Sir, you are in the concluding slide, you are telling about a sectoral, we have to create an indicator. Are we not following the indicators of Blue Economy Index or Blue Economy Development Index? This was my first question. And my second question is, the threat of sustainable blue economy is overfishing. Actually, our fishing stock, over and above, we are fishing 35%. That is what the statistics says. How this can be addressed? How this can be prevented? These are all my two questions. And the third one, if time allows, there is a habitat distraction. See, all our lands are being, areas being destroyed or being covered by urbanization. How this can keep our 7,500 kilometers of coastal area? Suppose you take in 2030 or 2050, what will happen? So it was one of the main challenge now or threat now. And apart from that, plastic pollution also. See, we have a very good plastic pollutions in all the seawater technology. And what are all the new cleaning technology which we can develop? That is also an area which we need to address. So these are all my four questions. If time permits, please, sir.
No, I will answer very briefly each of this. No problem. See, the issue of overfishing is, in my view, is exaggerated. The reason you see in many places, especially on Kerala fishermen, that they are not getting sufficient fish. Our study shows that after 1985, when the global warming started, the sardine and mackerel, the two main fishery on Kerala, Karnataka coast, has shifted to Maharashtra and Goa. Actually, last year, Maharashtra has a bumper crop of sardine. So total, also now you get sardine and mackerel on Andhra and Tamil Nadu coast, which was never available earlier. So I agree that on the Kerala and partly Karnataka coast, the sardine and mackerel are not available as it used to be before 1985, but the total sardine catch on the country is increased, especially Tamil Nadu, Andhra, and Maharashtra coast. So the fishery are shifting because of the warming, and this could be one of the main reason of it's not overfishing, but it's the our 90% of the fishing is between the sustainable limits. Our total yield could be 5.3 million tons. On an average, we have been harvesting only 3.8 million tons. So there may be a particular spot, a particular region, there could be issue. But in a general, we have been fishing within the sustainable limits. The indicators, why I said that we have to identify the indicators, there is no, when you start developing economy, and normal feeling is that once the industry comes, the ecology will suffer. So we have to now identify that what is that when you say suffer. Because I know in like mangroves on Gujarat and Maharashtra coast has increased, while it has decreased in Andaman and Nicobar, mainly because of the tsunami and the other hazards, the sea level rise. So there are many times the natural causes also does tremendous damage, not necessarily it that the human is only the reason for the damaging the ecosystem. So once we should identify these are the indicators based on which I will make a judgment. Now, that means you need to have a scientific evidence to find out whether the ecosystem is endangered or not. I'll give you example of a Gulf of Kutch. Before 1983, because of the mining of a coralline sand, the both corals and the mangroves were drastically affected, practically vanished. After that area was declared as a marine national park and the conservation efforts started, the things have come back. If you go today, you can see beautiful corals on Pirotan and many places, which has come back. The very dense mangroves have come back. So this way, we must first identify that based on this indicator, I am basing my. It should not be a general kind of a statement that the ecosystems are affected. I want to know which are the parameters which you would identify. So that is why I said the destruction of habitat, yes, this is true, especially when the cities are expanding, and that is mainly because of the population rise. If you see from in last 75 years, we have gone from 33 crore to 140 crore. So it's a huge population increase, and for that you need shelter, you need to have a settlement, you need to, all the required facilities have almost gone 5 times. So naturally, this habitat destruction. So sometimes, we need to also see that the requirement of our food, our water has gone almost 5 times. And to that provide naturally the habitats are being destructed. There is no doubt about it. And it's a question of between livelihoods and the ecology. And normally the livelihood will always win because it would be always a political decision. So we have to see that how we can use our knowledge to protect those habitats which are yet not affected. And that is why the marine protected areas and the biosphere reserves and all that are very critical for us to conserve whatever has been left, and whether how we can further control and mitigate already which has been destroyed. And of course, plastic pollution is more of a human created a problem. Plastic per se has a lot of advantages, but the way it is being disposed of creates a problem. So we must have a proper collection and recycling of the plastic. If you just leave it anywhere, especially you see everywhere, especially all tourist places, you see the people have just thrown their bottles and all those wrappers and everything anywhere. So it's a problem created by us, not by the plastic per se. So we must educate people to properly collect and recycle those plastics. Otherwise, this problem. So many times uh, the human awareness, what individual uh, may be doing. Most of the time, we think if I throw here, how does it matter? But then everybody throws. So ultimately, it becomes a problem. I think human awareness is very critical for the controlling the plastic pollution. So thank you very much for excellent questions. Thank you.
Thank you, sir. Thank you very much, sir.
Thank you very much, sir. Any other questions? Sir, I have one question.
Yeah,
it's
please.
a general question from the student side. Sir, which led you to work in the oceans? This is not the place we see in our daily life.
Yeah, actually, I started my career. I mean, my PhD was on the bauxite, genesis of bauxite, but I happened to join Space Application Center in '78, and we were looking at various satellite images. It was just beginning, and I got interested by looking the images of Gulf of Cambar. There were several different shades, and I had some background in geomorphology and all. So I started looking at it where the first time we given the uh, path of the suspended sediment, how they move in a gulf and sheltered areas. So we gave some kind of a model that how they are moving, and that led to from sediment I shifted to phytoplankton, and since then we had a plan to launch a satellite on ocean color. So I continued to work on the ocean because I fascinated by the kind of information which ocean color gives. Actually, when you see ocean, it could be brown, it could be blue, it could be green, it could be various hues of shades. And we are very happy to see them and say, oh, fine. But we started looking at why these different colors coming. What are so mainly it is because of the sediments and phytoplankton, and of course the degraded organic material. And once you you can build algorithms to find out each component. There are very complex methods of doing all this. But then once you have those information, I showed a couple of examples how this information useful to develop the fishery service or primary productivity or algal blooms or understanding the health of the ecosystems. So there are n number of uses of the simple ocean color. So that is how I got into this basically.
Thank you very much, sir. Sir, there are two questions but it is one. Due to global warming, the sea level is supposed to increase in coming years. What will happen to the residents of the coastal areas? And the second is that about the carbon credits. How get we get data locally and how it is important for industries near coastal areas?
Yeah, I think it's very important. The sea level is rising. I showed you one example of the Orissa coast. Once the sea level rises, most people believe it will simple inundate, and people, if it is 3 millimeter, it will height of 3 millimeter get it. It is not happening that way. When sea level rises, most important thing is the existing equilibrium between the land and sea, where you can get a different kinds of features like beach. This equilibrium gets disturbed. And to maintain this equilibrium, many places the sea start eroding. So you will get a sea erosion. In the areas like estuaries and the river mouths and all, what happens is now the amount of water which has to go and come back because of the tidal effect, the volume of water increases. So you will find that river mouth gets widened. So there is a change in the pattern of a sediment transport, the interaction between the land and sea, and many such things happens. And because of that, yes, the settlement do get affected. So wherever there are settlements there are engineering methods by which you can protect it. But overall, these all engineering structures also which you can do will transfer the problem from place A to place B. So if I want to protect, say, Bombay, and if I can create engineering structures, I can protect the Bombay, but the north and south of Bombay will be get affected. So we will have to take a very conscious decisions which area needs a protection, because ultimately till the equilibrium is reached, there would be erosion. The one famous examples are when you dam the river. One famous example is on the Mahi River in the Gujarat where we worked. When the dam was constructed and the flow got reduced, there was a huge erosion occurred. And this continued for several years, 10, 15 years. But after that, the new flow, the equilibrium was brought and the erosion has stopped. But there was a drastic change into the Mahi River mouth between 67 and 1967 and 1990. Similar thing happened in the Narmada also. And all major river which has been dammed, if you see, there would be huge changes on the mouths. So this will definitely happen. And we have to address these issues. So wherever there are huge settlements, you will have to have engineering structures to protect that property. And the second is about carbon credit. Yeah, I mean, this is being done in a way that if you do not put that much carbon into, and there is a method by calculating the cost, so they try to find out that cost and put it. But still, there is no as such a market in India where you can really trade it. But in a way, this is can become a problem in a sense that the rich nation can purchase the credit from the developing nations and continue to use the energy as they wish. So, in my view, it is more important to reduce the footprint of carbon dioxide. That is the most important than gaining the credit. If you are getting the credit by natural means like mangroves, that is okay. But this could be very dangerous. That means those who have a money will survive, and those who do not have a money will not survive. So it's not a equity. There is no equity in this carbon credit. So we have to be very careful to get involved in this carbon credit business.
Sir, I have one more. You are talking about money. So any universities or organizations or government agencies getting support from UNEP, United Nations Environmental Program? Are we getting any support from them financially?
No, I think there are maybe many such. I mean, I personally don't know how much support is coming, but this programs is handled by Ministry of Environment and Forest, and there are certain things which is happening, but I'm not sure whether they are funding directly to any institutions by and large. It has to come through this ministry's program, I think. It is not direct funding, but there could be. I'm not very sure whether they entertain proposals directly from academic institutes.
Thank you very much, sir, for addressing the queries of the audience. Gradually, as we near the conclusion of today's program, I would like to invite the Secretary, Shri Vaishnav Vidyapit Trust, Shri Kamal Narayan Ji Muradia, to present the words of thanks.
आज के हमारे कार्यक्रम के मुख्य अतिथि पद्मश्री प्रोफेसर शैलेश नायक जी, नेशनल इंस्टीट्यूट ऑफ एडवांस स्टडीज बेंगलोर, TRI स्कूल ऑफ एडवांस स्टडीज नई दिल्ली के चांसलर एवं अन्य कई संस्थाओं के एक महत्वपूर्ण नायक, हर जगह आप एक नायक के रूप में हैं। वैष्णव विद्यापीठ विश्वविद्यालय के कुलाधिपति श्री पसारी जी, वाइस चांसलर डॉक्टर उपेंद्र धर, प्रोग्राम ऑर्गेनाइजर डॉक्टर उत्तम शर्मा, कार्यक्रम में उपस्थित सभी फैकल्टीज HOD एंड सभी आमंत्रित अतिथिगण, आज हमारे लिए ये अत्यंत ही गौरव एवं प्रसन्नता का विषय है कि आज हमारे 9वें विक्रम साराभाई मेमोरियल ऑरेशन के मुख्य अतिथि के रूप में देश की जानी मानी हस्ती एवं वैज्ञानिक पद्मश्री प्रोफेसर शैलेश नायक जी उपस्थित हैं। उन्होंने हमारे इस कार्यक्रम में सम्मिलित होकर हमें गौरवान्वित किया है। आपके प्रेरणादायी उद्बोधन से हम सभी लाभान्वित हुए हैं। इस हेतु पूरा विश्वविद्यालय परिवार सर आपका हृदय से आभार व्यक्त करता है। आपने इस कार्यक्रम में अपनी उपस्थिति से हम सभी को हर्षोल्लासित कर दिया है। निश्चय ही हम आपके बहुआयामी व्यक्तित्व के प्रकाश में अभिभूत हैं। सर, इतना नॉलेज आपका है कि मैं आपके लिए यही कहूंगा कि मिन्नत मिलते हैं मिन्नतों से ऐसे मेहमा कभी कभी, मिलते हैं मिन्नतों से ऐसे मेहमा कभी कभी, हो जाती है किस्मतें यूं मेहरमा कभी कभी। जज्बात जग जाए, नया हम सब भी कुछ करें, देखा तो आपको लगा हम भी तो कुछ बने, मिलती है किसी किसी से इतनी प्रेरणाएं कभी कभी, हो जाती है किस्मतें यूं मेहरमा कभी कभी। निश्चय ही आपके इतने अटूट ज्ञान से इस वर्चुअल कार्यक्रम उपस्थित सभी को ब्लू इकोनॉमी के बारे में विस्तृत जानकारी मिली है एवं सोच का एक नया विजन मिला है। मैं इस अवसर पर उपस्थित कुलाधिपति श्री पसारी जी, उपेंद्र धर जी, उत्तम शर्मा और उनकी टीम एवं सभी का एक बहुत आभार व्यक्त करता हूं कि जिन्होंने इतना अच्छा प्रोग्राम करा और विशेषकर इतने अच्छे अतिथि को बुलाया है। सर, हम जैसा कि हमारे तो हरि शुरू से ही कहा गया है, समुद्र स्तोत्रों का भंडार है और हम तो पाताल, हमारे जो वेद हैं उपनिषद हैं, उन्होंने तो इसके नीचे पाताल लोक भी बताया है कि समुद्र के नीचे पाताल लोक भी है और उसमें अपार क्षमताएं हैं। और इसका हम उसका आज के साइंस के साथ इसका आप दोहन भी करें और आप जैसे महानुभाव मिले हैं जो आज इतनी बड़ी पॉपुलेशन को, अगर समुद्र न हो तो हम इतनी बड़ी पॉपुलेशन को कैसे जीवित रख सकते हैं। तो हमारे समुद्र का हर क्षेत्र में और ब्लू इकोनॉमी का हर क्षेत्र में बहुत ज्यादा योगदान है और इस योगदान को आप जैसे लोगों ने ही इसे आगे बढ़ाया है। आप वास्तव में एक बहुत बड़े आप बहुत बड़ी देश की सेवा कर रहे हैं। निश्चय ही आज के आपके ज्ञान एवं अनुभव से हमारा उभरता हुआ विश्वविद्यालय समृद्ध हुआ है। हमारा आपसे विनम्र निवेदन है कि आज आप हमारे कार्यक्रम में वर्चुअल रूप से उपस्थित हैं, लेकिन हम चाहते हैं कि हमारा जैसे कि एक सहारा है ना कि सर दिल अभी भरा नहीं, दिल अभी भरा नहीं। आप ये शख्सियत हमारे विश्वविद्यालय में प्रत्यक्ष रूप से उपस्थित हो। हम चाहते हैं कि आपके चरण हमारे विश्वविद्यालय की भूमि में पड़े, हम आपका मार्गदर्शन व्यक्तिगत रूप से प्राप्त कर सकें। जैसा कि आपको विदित है कि पूरे देश में लगातार 7वीं बार इंदौर को स्वच्छता में प्रथम पुरस्कार मिला है। अब मैं चाहता हूं आप इंदौर अवश्य पधारें और हमारा आतिथ्य स्वीकार करें। मैं पुनः आपका आभार व्यक्त करता हूं और मैं आपके लिए यही कहूंगा कि कदम आपने ऐसे रखे कि निशान बन गए, कदम ऐसे रखे कि निशान बन गए, वो कार्य ऐसे किए कि पहचान बन गए। जीवन तो सभी जी लेते हैं सर, पर आप ऐसे जिए कि मिसाल बन गए, आप ऐसे जिए कि मिसाल बन गए। सर, आपका इकबाल और बुलंद हो। विश्वविद्यालय परिवार ये मंगल कामना करता है कि आप स्वस्थ रहें, शतायु हों। आप तो देश की सर धरोहर हैं। आप नित्य नए नए रिसर्च करते रहें, हम देश तथा समाज की इसी प्रकार सेवा करते रहें, यही हमारी शुभकामना है। पुनः मैं आपका आभार व्यक्त करता हूं, आपको इंदौर के लिए आमंत्रित करता हूं एवं सभी आमंत्रितों उपस्थित महानुभावों का भी मैं आभार व्यक्त करता हूं। जय हिंद, जय वैष्णव। थैंक यू सर, थैंक यू वेरी मच सर।
Thank you. Thank you very much. Thank you.
थैंक यू सर, थैंक यू।
Thank you very much, sir. Once again, I express my sincere thanks to all the dignitaries and delegates for taking time to join us through the online platform. I request all of you to please rise up at your place for the national anthem.
मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Jai Hind.
Thank you very much.
Thank you very much, Professor Naik. Thank you.
Thank you, sir.
Thank you very
I
much.
request you to visit Indore. Send
नहीं
you
जरूर
an
आएंगे
invitation
इंदौर
soon.
जरूर आएंगे
Yeah. Thank you.
हाँ, जरूर
धन्यवाद.
आएंगे या जरूर आएंगे थैंक यू
Thank you very much, sir,
Thank you.
for joining. With this, we'll close this event. Thank you very much to all of you.